I am Anil Kumar and I am sharing some very good questions on inverse of quadratic function with you. These are from the previous test paper. Given graph of the function f of x equals to 3 times x plus 2 whole square minus 3. Graph inverse of the function. State domain range of f of x and its inverse. How can you restrict f of x to ensure that its inverse is a function? So I'd like you to copy the graph and then sketch the inverse. After you sketch the inverse, you will see the domain range and you can write your answer. Now the third part is restricting domain so that the inverse is assured to be a function. So answer these questions and then look into my suggestion. Here is my suggestion. Now to draw inverse, what I can do is I can take few points and then swap those points, get the new points and draw. So that is one way of doing it. The second way is I can reflect the points on the line y equals to x. So there are two ways to do it. So let me use both the strategies in this particular graph and show you the solution. Now one good thing is whenever you see a graph like this, so these points where you find intersection of y equals to x with the graph, these are invariant points. So mark them. They don't change their position. So that is the first thing you should take care of. Now let's start with the right half of the graph. In the right half of the graph, let's take the vertex as the most critical point. Now vertex, if you reflect, it is half unit on the diagonal, so we get a unit here. That becomes the new vertex. Now we will not consider that point for the time being. We are moving right. Now the second point is the invariant point, which we'll leave for the time being. And that means this and then joining that point. And then let's take another good point on the graph, which is this. So it can be reflected. One unit diagonally will give me that part here. Now that's another good point. Now let's say take this y-intercept. Now here 1, 2, 3, 4. So let's count 1, 2, 3, 4. So it comes at 8. It becomes x-intercept. Always you will find that the y-intercepts will swap to x and x to y, right? So we already have a couple of points to join with 1, 2, 3 and 4. So if I join these points, I get the inverse of 1/2 of my parabola. Correct? Now to do the other half, we can continue with the same strategy. That is one part. Second, we can also use a new strategy, and that is swapping the points. So let's swap the points this time. So this point for us is -4, 8, right? -4 and 8. So if I swap it, it becomes 8 and -4. So let's locate 8 and -4. So 8 is here and -4 is there. So we get a new point, which is right there. Similarly, we can have some more points. Look for some good points. Let's say this. Now that is on the x-intercept. It will definitely come on the y. This point is -3, 0. -3, 0. So that will become 0, -3. So that is this point for us, which is 0, -3. Do you get it? Now, and this is invariant, and we do have the vertex. So we got 4 points to join. So we can join these points with a curve. So this line reflects the left half of our parabola, and we have now kind of 2 halves of square root functions, which indicates inverse of the given function. Do you see that? Now from here, we can answer the second part. So we're done with the first part, and I've shown you 2 techniques. Domain of f of x and its inverse. As far as f of x is concerned, domain is, let's write domain and range, right? Of f of x first, let us say. So for f of x, and then we write f inverse x. So let me use different ink for both. Now for the first one, f of x, the domain is x belongs to real numbers, right? And the range is y belongs to real number, but it is greater than equals to this value, which is -3. Now, For the inverse, as you can see, now the domain has got restricted. It is x belongs to real number where x is greater than equal to minus 3. Do you see? X is greater than equals to minus 3. As you can see, the values are swapped. Do you see that? That is how it will always be. And the range is y belongs to real numbers. So when you do inverse, then the domain and range also swaps. The last part is, how can you restrict function to ensure that its inverse is a function? Now inverse is clearly not a function, since drawing a vertical line here will give you 2 points intersection. So the way to restrict is, as you can see from here, restrict the domain of the function. So we can say let x be greater than equal to that vertex point which is at minus 2. So if we consider only one half, that is x greater than equal to minus 2, we are considering the right arm of a parabola whose inverse will be this red portion shown on the top. That will be a function, right? Or we could say x less than equals to minus 2. In that case, we get only this line as the inverse of this left side of the parabola. So it becomes a function. So that is how we can answer these questions. I hope you understand and appreciate it. Now the next one, I'll not give you any help, and you need to answer it in complete details just as I discussed it. Thank you and all the best.